But first, I want to finish what we looked at for significant figures, which are important in measured values. So when you take a measurement using a ruler or using a graduated cylinder or a beaker that we're going to do all in lab next week, it becomes a measured value, which is a number value that came from measurement. And so those number values that are measured have what are called significant figures. It's not just a regular number. Now it has a certain number of significant figures attached to it. So we have to define what significant figures are for any number value. Okay, so we went through this last time. So you have all those digits 1 through 9 are significant. So the 1, the 2, and the 9, that has all of those are significant, so that's 3 sig figs. Captive zeros are zeros in between significant digits. These are the 5 and 7 are significant because those are digits 1 through 9, and then those zeros are in between significant digits. Those are called captive zeros, and those are always significant. So this has a total of 1, 2, 3, 4 significant figures. Now you have leading zeros. So leading zeros, those are to the left of your number value, and those are never significant. So starting with the 2 and the 5, those are the digits 1 through 9, so those are significant. But the zeros all at the left, even though there's a decimal there, zeros at the left are leading zeros, and those are never significant. So the only significant figures are the 2 and the 5. So 2 significant figures in this number value. And then finally, this is the most complicated one, are called trailing zeros. Trailing zeros are at the right of a number value. Now, these are only significant when there's a decimal, which is why I added this even with a decimal to the leading zeros. So when there's a decimal present, that makes the zeros at the right of the number value significant. So in these examples, you've got the 2 and the 5, and then these are zeros at the right. These zeros at the right have a comma but no decimal. So therefore, only the 2 and the 5 are significant figures. Okay. This is another example here with a 2 and a 5. Okay. We have zeros to the left, and these zeros to the left, I'm actually going to switch this to red. These are not significant because these are leading zeros, and those are never significant. You have the zeros to the right. I'm going to switch to green. These zeros to the right are significant because there's a decimal there. This is in green, okay? The previous number had a comma but no decimal. So this has the 2 in green and the 2 in blue, and that's a total of 4 significant figures. And then let's keep this on green actually. We've got this number which has the 2 and the 5. The 2 and the 5 are the non-zero digits, significant. And then you've got a 0 on the right with a decimal. So that's a trailing 0 with a decimal. That makes that significant, so green. You have the 0 on the left. Even though there's a decimal, the 0 on the left is not significant. So this number has those significant figures are the 2, the 5, and the 0, 3 sig figs. Okay. Also have number values that are not measured values. These are values that are counted. So for instance, if I decide to count how many students are sitting in the corner over there, because I've got a bunch of students sitting in my living room, I count 18, which is not a measurement value. That's actually called a head count. And so that's because you can't have fractional numbers when you're counting. So counted values are considered infinitely significant. And so are these other non-measured values. So conversion factors are used to convert measurement values, but those are not measured, okay? Constants, those are also not measured values. All of these are considered infinitely significant, and basically you don't need to deal with them when you are looking at sig figs. Okay, that's infinitely significant. 1,000,000 sig figs is what you could think of these, and so they're not ever going to limit any types of rounding off when you are dealing with calculations with significant figures. Okay, so I've got these examples where you need to determine the number of sig figs in these values. So we've got this 804. The 8 and the 4 are your non-zero digits, and then you have this 0, which is a captive. So that has 3 sig figs. This 8, number 2, has an 8, and it has a decimal, and then zeros after the decimal. So those are zeros on the right with a decimal. Those are significant. Trailing zeros with a decimal, always, those are significant. Let's look at, I'm going to switch to green and red now. This one has a 3, number 3, and then there are zeros on the right. Those are significant because there's a decimal. Switching to red, when you have zeros on the left, those are never significant, even if there's a decimal. So this one has a total of 3 sig figs. Okay, so we've got number 4 has this 8, the non-zero is significant, and then these zeros are significant because there's a decimal there. Okay, now how to handle this 10 squared? So that is reason why we have scientific notation, is that it takes the questions out of sig figs. So this is not part of sig figs. It's not that it's not significant, it just doesn't factor into our sig fig determination. So all we have to look at is the coefficient part, not the power of 10. And so this number has those 3 sig figs, and this we don't worry about, the power of 10. Okay, for number 5, we've got, this is a 9, and then you've got all of these zeros, which are trailing zeros with no decimal. There's a comma here, but no decimal, so those are not significant. So this number value has only the 1 sig fig. Now this will become important in calculations, where this number, having only 1 sig fig, will limit our answer value and require us to round off. We'll be getting to that. Okay, so for number 6, I've got this 1 times 10 squared. So we already know, don't need to look at this 10 squared as far as sig fig calculations. It certainly is effect on the number, but what this means is you have just this 1, that is 1 sig fig. If we were to expand this scientific notation into standard notation, this is a 1 with 2 zeros after it, this would still have just the 1 sig fig, that 1, because those are zeros with no decimal. So this still has 1 sig fig. Okay, so let's take a look at this next example. 3.01 times 10 to the 21st. Again, we don't look at the power of 10. And the coefficient part with the decimal has the 3 and the 1. Non-zeros are significant. This is a captive zero, that's significant. And so this has 3 sig figs. Okay. Number 8 is pi, which you could write out 3.1427, et cetera, but ultimately this is infinitely significant. Okay, and we don't look at those when we're dealing with calculations as far as sig figs. Okay, and then this is a conversion factor, 12 inches equals 1 foot, and this is also infinite. All right, so we had looked last time at the metric prefixes, and we're going to use them and go back to that worksheet. But first, let's revisit this metric prefix, some of these symbols. So we've got, this is kilo, which is K, hecto is H, deca is DA. Okay, all of these are greater than the basic unit, which is considered 1, and these are powers, where powers of 10. Kilo is 10 to the 3rd, hecto is 10 squared, and deca is 10 to the 1st. There are higher powers beyond that on the list that we looked at last time, and we'll look at again, but this is just basic, right around the basic unit. So deci is a lowercase d, which is very close to dA. That's deca. Deca and deci are very close. Deca is 10 to the 1, and deci is 10 to the minus 1. Okay. Centi is a lowercase c, that's 10 to the minus 2, and milli is a lowercase m, that's 10 to the minus 3. Okay, and so one thing you have is that you might just have learned this a different way, where you just have to think about these steps in order to do conversions. But I prefer this method where you set up a conversion factor, okay? But this is an example of what you'll see in your Connect assignment number 1, is express 1 meter in terms of dm, cm, and mm. And so let me show you how to go about this. If you have dm, what we have is starting with deci, which is 10 to the minus 1. Okay, so you start with the power of 10 that metric prefix symbol is equal to. And ideally you have that memorized, so it's quick, but you can always look at your notes. Then you want to add the unit onto both sides of that. So dm equals 10 to the minus 1 m, and then you have a 1 in the front. Okay, and so if we want to make this 1 meter in terms of decimeter, then basically you are taking this and turning this into 1 meter equals 10 squared, or 10 to the first decimeter. Okay, so and that will work for the same for centimeter and millimeter, so that you basically have the inverse of that minus 1 becoming 1 when you have the representing it as 1 meter. Okay, so this is the next one is, sorry, what just happened here? Here we go. Let's take a look at these guys, the decameter, hectometer, kilometer side. So again, if you were to start with, my hand is making this move, decameter, dA, deca is equal to 10 to the first. Okay, so you want to start with the metric prefix little symbol and the power of 10 it's equal to, add the units onto both sides. Decameter equals 10 to the first meters. I put the m on both sides of the equals, put a 1 in the front, and you've got a conversion factor. Okay, this time though, if you want to have the decameter because it's greater than, this will end up being 10 to the minus 1 decameter, the opposite of that 10 to the 1 that's equal to 1 meter. I'll put it on that side to make it equal. Okay, so whereas this one was the 10 to the minus 1 meter, this one was 10 to the 1 meter, and so that inverted to 10 to the minus 1 decameter. Okay, so in conversions using metric prefixes, the goal is to set up a conversion factor and then cancel the units when you are using one. So in this example, I think this is on your worksheet, so you could work this out on that worksheet, is convert 155HM to M. Okay, and so which worksheet is it on? I think it's on the, no, it's actually not on there, it's 55. So 155HM to M. You start by identifying the metric prefix, which is an H. So you want to set up a conversion factor using H. This would be H equals 10 squared. Okay, we want to add the units of M onto both sides. So this is going to be HM equals 10 squared M. Put a 1 in the front, and that'll be the conversion factor I'm going to use. Okay, so how to use this is you take the number that you're trying to convert and write it down, 155 HM. Now you want to put this conversion factor into a fraction form. So what I do is I write parentheses and then a horizontal line and decide what's going on the bottom so I can cancel these units, which are HM. Okay, so what's going on the bottom is going to need to be something to cancel, so I'm going to circle that I want HM on the bottom. HM on the bottom with the 1. So this whole thing on this side, the equal sign 1 HM goes in the bottom of this fraction so that I can cancel HM is the goal. Now on the top of this fraction goes what's on the other side of this equal sign, which is that 10 squared M. Okay, and so what you've done is you've canceled out HM, which means that, I'm going back to my blue pen, is that you can write the equal sign and the units that remain are what are not crossed out, which is this M. And I can write it out here to the right, leaving a bunch of white space for the number value. The number value being 155 times 10 squared. So 155 times 10 squared, and then meters are the units. Okay, so this is the answer. Just for practice, let's convert this answer into scientific notation, which means put a decimal here, move it over 2 places so that this becomes a number more than 1, less than 10, 1.55. Okay, so when this 155 became 1.55, that coefficient went down, so the exponent value will go up. So it went down by 2 powers of 10, so this exponent goes up by 2 powers. 1.55 times 10 to the 4 meter would be your answer in scientific notation. Number line really helps for negative exponents, and hopefully you guys have seen this at some point in your life. And number line is really helpful for negative exponents. It's something I referred to very quickly and briefly in the last lecture, which is that when a negative exponent becomes gets smaller, it means it moves further away from 0. Okay, so going from -7 to -8 is becoming smaller, even though it might seem like 7 versus 8, but it's in the negative side. And so when in the negative exponents, moving this direction means that your negative exponent value is larger, whereas 10 to the third to 10 to the second, 10 to the -3 compared to 10 to the -2 is going in the positive direction and larger. Okay, so this is in thinking about when you have converting to scientific notation and you're dealing with what happens to the negative exponent. We'll see these examples here. Okay, so let's take a look at, I think we just did this one, 155 to HM to M, and put the answer into scientific notation. So let's take a look at this one, 155 M to meters, and put this answer into scientific notation. So again, we have, actually 155 M to M is the same thing. So I must be 155 HM. Okay, so 155 HM we already did. So 155 M to HM, let's do that. Okay, so we had this HM, 1 HM is 10 squared meters. That was the conversion factor we had from the previous slide. And we're going to reuse this conversion factor. Okay, so this is going to be the number we're converting is 155M, and I want to convert it to HM. I'm going to fix that on my slide. Okay, this time I'm going to use the same fraction. So this is a parentheses with the horizontal line, but this time what's going on the bottom isn't going to be this 1HM. This time what's going on the bottom is 10 squared M. Why? Because I'm trying to cancel meters. Okay, so this is because the original number is meters, and so this 10 squared meters goes on the bottom. This is 1 HM on the top. Oh, that's better, and those are still canceled out. So this means the units that remain are HM, and what we have here is 155 times 1 over 10 squared HM. See, this 1 and 10 squared are just part of this fraction that I moved over here. Okay, and the 155 I just moved to the other side of the equal sign. So I want to show you how that works, is that this 1 is equal to 10 to the 0. Okay, and so this is something where we can turn this 1 into 10 to the 0 over 10 squared. This is the same fraction, except for instead of a 1, I have 10 to the 0. And what we have is when you have a fraction with exponents, you subtract the exponents. Okay, this is because when you're dividing, you subtract when dividing with exponents. And so this is subtracting those exponents, 0 minus 2, which would be -2. So therefore, this answer is 10 to the -2. Okay, now I know the short answer that a lot of you are saying, oh, this is easy. It's just, you invert the 2. 2 becomes -2. But it's a little more difficult when you're dealing with negative exponent on the bottom. Okay, so this is why that works. So if you have this answer is 155 times 10 to the -2 HM. Now we want to convert this number into scientific notation. And so this is going to be 155, put a decimal, move it over. This becomes 1.55, okay? And this is times, let's figure that out. So 155 to 1.55 is a number going smaller, the coefficient's going smaller from 155 to 1.55, and that means the exponent has to get larger. So this exponent being in the negative exponent land is something to go tread slowly, okay? So getting larger by two powers of 10 means getting closer to 0. So this actually becomes from 10 to the minus 2, 10 to the 0. So 2 orders of magnitude larger, 10 to the minus 2 to 10 to the 0. Some people are, you'd be tempted to write 10 to the minus 4. Don't do that. That's getting smaller. Okay, and then keep your units HM. So that's 1.55 times 10 to the 0 HM, and that's in scientific notation, which has the power of 10 associated with it. Okay, so let's take a look at this one, 155 DAM to HM. Now in this one, we have two metric prefixes, so we're going to need to set up two conversion factors. One for DA, which is deca, 10 to the first. And this is going to be a decameter, so I need to multiply the m onto both sides. DA decameter equals 10 to the first meters, and then put a 1 in the front, and that's your first conversion factor. This one is HM. I think that says HM. Let me erase this because, yep, that's still HM. Okay, so go back to here. I want second conversion factor with H. H is 10 squared. So to make this HM, I need to multiply m onto both sides. HM equals 10 squared m. Put a 1 in the front, and that's going to be another conversion factor I'm going to use. So I'm going to take the original number, 155, rewrite it down here, and set up to use two conversion factors. Okay, so first I should add that you note I wrote the number with the units. Oftentimes I see students just write the number and you forget about the units, and then you're stuck because you don't know what you're supposed to cancel out. Okay, so write the number with the units, and then since we have two conversion factors, you're going to make space for two conversion factors. That means two parentheses and two fraction lines. Okay, two horizontal lines, two parentheses. And then it's a matter of deciding what is going where. Okay, so let's switch to orange, and we have decameter. So on the bottom, I'm going to want to put decameter. The only option is this 1 decameter from this conversion factor. This is so I can cancel out the DAM. On the top of this fraction goes whatever was on the other side of the equal sign. In this case, it was 10 to the first m. Okay, so I've used this conversion factor, and I don't need to use it again. In the second conversion factor, we're still driven by what are we trying to cancel out. So these are gone, what I've crossed off, okay? So what's left here is this meters. So that will help me decide what's going in the bottom of this second fraction. That's going to choose, I'm going to choose 10 squared m. And that's because I want to cancel out this meter with that meter. Okay, so then what's going on the top of this fraction is what was on the other side of the equal sign, which is 1 hm. Okay, so that leaves just a bunch of numbers, and this is the only unit, the HM. So that means that switching back to blue, I can write an equal sign. The units that are left are HM. That's the units I'm trying to solve for. Good, so that means I've set everything up correctly. And so this is going to be compressing these numbers. I've got 155 times what was on the top is 10 to the first. Let me find a different color here. 10 to the first is on the top. There's also a 1, but we can just compress that to 10 to the first times 1. And then what's on the bottom is a 1 and 10 squared, so that can just be 10 squared. Okay, so in just looking at those exponents, this is a dividing exponent, so 1 minus 2, negative 1. So this is going to be equal to 155 times 10 to the minus 1 hm. And then let's convert this to scientific notation. So put a decimal here, move it over 2 places, and you have 1.55. And this is going to be, this 155 went down to 1.55, so the exponent has to go up. So from 10 to the minus 1, it's going to increase from minus 1 to 0 and 1 because this went down by 2. This goes up by 2, and that gets me to 10 to the 1. So I actually use that number line. Having a number line is really helpful. Okay, so that is 1.55 times 10 to the first hm. those metric prefixes and setting up the conversion factors. So this is the metric prefix K, which is kilo, 10 to the third. We want it to be kilometer, so put M on both sides, which is going to be km equals 10 to the third m. The most common mistake I see is just having it km, and you forget to write the meters on this side. Okay, so you want meters on both sides and then put a 1 in the front. We're going to use this conversion factor to convert 155 km. So put your parentheses with the horizontal line and decide what's going where. So this units of the number you're trying to convert are km, so you want km on the bottom this time, 1 km, so that kilometers and kilometers will cancel out. And then what's going on the top of this fraction is 10 to the third meters. Okay, so that was just what was on the other side of the equal sign. These units are canceled out, so what's left is this meters. Leave some white space, put the units that you have left, and check. Yep, those are the answers. That's what I was trying to get to. So now you can go to the numbers. And you'll notice that I haven't needed a calculator yet, right? So that's good. Because if you can do as much as you can do without a calculator, as much as you can do writing down, you're much better off, because as I mentioned last time, the more you write down, the more you're activating that pathway to your brain, directly to your brain, to remember these things. So this is 155 times 10 to the third. We want to put this into scientific notation. So this decimal goes here, move it over so that you have 1.55. This went from 155 to 1.55. That got smaller, so this exponent needs to get bigger by 2, so 10 to the 5th meters. Okay. In number 2, you have 155 meters this time. And how many kilometers? So we can use this same conversion factor, but what we're looking at this time is the units are 155 meters. So we need meters on the bottom of this conversion factor. So let's choose this time. Let me change this to orange, red. No, red's too dramatic. Green. Okay, so 10 to the third meters are going on the bottom because I want to cancel meters and meters. Okay, you can reuse, recycle this conversion factor. And then 1 kilometer is going on the top. That was what was on the other side of the equal sign. Okay, so we've got meters and meters canceled out. What units are left are kilometers, so leave some white space for the number, and you have the units are kilometers. That's what I was trying to get to. So that means you can go to the numbers, which are 155, and this is times 1 over 10 squared. That's just what's here. So remember how I handled that is 1 is 10 to the 0, so I turn that 1 into 10 to the 0 over 10 squared. I did that because then I can really understand what's going on when you're dividing exponents. You subtract them. 0 minus 2 is minus 2, so this is going to be 10 to the minus 2. So this is 155, going back here, times 10 to the minus 2 km. Okay, and then take this number, put it into scientific notation, put a decimal here, move it over 2, and you have 1.55. That got smaller. So our 10 to the minus 2 needs to get bigger, which is getting closer to 0. So this is 10 to the 0 km. Okay. All right. So number 3, we have 155 DAL to liters. So let's start with the metric prefix DA, and that's 10 to the first. Okay. So when you want to add the units liters, you multiply liters onto both sides. DAL equals 10 to the first L. Put a 1 in the front, and that's going to be the conversion factor. Okay, so we're taking 155 DAL and make a fraction with the horizontal line and decide what's going on the bottom. So using this conversion factor, you have 1 DAL on the bottom. That's because I want to cancel out decaliters. On the top is what's on the other side of the equal sign, 10 to the first liters. And that is the units that are remaining are liters. So leave some space, put the liters over here, and then now you're set because that's the units we're trying to get to. Go to the numbers, which is 155 times 10 to the first. It is, I'll circle this in green, it is 10 to the first over 1, and you'll notice I'm not doing this, conversion of 1 to 10 to the 0 because you don't actually need to do that when it's over 1. This one we can get rid of. So this is an example, here we go, here back to blue. Putting this into scientific notation, from 155 we go down to 1.55. That number got smaller, so the exponent needs to get bigger. So 1.55 times 10 to the third liters. Okay, for number 4, I'm looking at 2 metric prefixes here. Remember, it doesn't matter if they're on, you have this one on this side of the equal sign, this one on that side of the equal sign. Anytime there's a metric prefix anywhere in the problem you're trying to solve, you're going to set up a conversion factor. So this is a C, which is centi, 10 to the minus 2. This is a T, uppercase T, which is tera. This is 10 to the 12. Terabytes of data, that's the same tera. Okay, so this is C. We want to have the units of G onto both sides, so CG equals 10 to the minus 2 G. Put a 1 in the front, and that's going to be one of your conversion factors. Here we've got a tera TG, so we want to put G on both sides. TG, teragram, equals 10 to the 12 grams, and put a 1 in the front. So now we're going to use both of these to convert this number 155 CG. So take this number and write the number with the units, 155 CG. And now to use both conversion factors, put 2 parentheses and 2 fractions. And decide what's going on the bottom. Okay, so what's going on the bottom is we want to cancel out this CG, so take this 1 CG and put it down there. And then you can cancel centigrams. What's going on the top of this fraction is the other side of the equal sign, 10 to the minus 2G. Okay, so in the second fraction, we're being driven by trying to get rid of this G. So this gram is going to be 10 to the minus 12 grams, or it's 10 to the 12 grams. And then on the top, so the grams and grams will cancel out, and 1 teragram on the top. Okay, so we've got, this is going to be TG, and this is 155 times 10 to the minus 2 over 10 to the 12. Okay, so just looking at that, we've got minus 2 minus the 12. So this is going to be negative 14, and so this is going to be 155 times 10 to the minus 14 TG. Okay, so you got a decimal, move it over 2 places, and this is going to be 1.55. This number got smaller. The exponent has to get bigger. When you're in negative exponents, go slowly. So this is going to be getting bigger, means getting closer to 0, 10 to the minus 12 TG. Okay, so we've got number 5, which is, again, 2 metric prefixes in here. So we're going to set up 2 conversion factors. This is the symbol micro. It's the Greek symbol that stands for micro, 10 to the minus 6. Okay, and then you also have T, which is tera, and that's 10 to the 12. So we want to make this a microgram and a teragram. So this is going to be microgram, multiply G onto both sides. Put a 1 in the front, and that's your first conversion factor. This is a teragram, put a G on both sides, and that's your second conversion factor. Take this number, 155 micrograms, rewrite the number with the units, and then you're going to write 2 fractions and use both of these conversion factors. So we've got micrograms is what we want on the bottom, so I'm going to choose 1 microgram and cancel. On the top is what's on the other side of this equal sign, which is 10 to the minus 6 grams. Okay, so on now we've got micrograms gone, grams are what's next, so Canceling grams means we're going to put 10 to the 12 grams on the bottom. Grams and grams will cancel out, and you have 1 teragram on the top. The only units that remain is this teragram. That's good because that's what we're trying to get to. So once the units check out, then you can save some space for the number and write the TG units. Now we can do the calculation. We've got 155 times, and I'm just going to compress this number. Let me circle this in green. This is on the top, which is 10 to the minus 6, and then on the bottom is 10 to the 12. I'm just going to make this a single fraction, and we don't need any of those ones. Okay, so 10 to the minus 6 over 10 to the 12 is dividing exponents. So this is minus 6 minus 12, which is going to be negative 18. So that means this is going to be 10 to the minus 18. Okay, and so it really is helpful. It helps me a lot to write all this down. Let's rewrite. So we've got 155 times 10 to the minus 18 TG. Take this number 155 and put it into scientific notation. This becomes 1.55. So that again went down, 155 to 1.55. So the exponent needs to go up. So this is in the negative values. Go slowly. Think about getting larger means getting closer to 0, 10 to the minus 16. And that would be your answer in scientific notation. Okay, people are telling me what I did here. This should have been 10 to the third down there. Okay, sorry guys. So kilo is 10 to the third. That shouldn't have been 10 squared. Sorry about that. So I gotta fix this. Let's do all this in red. Thank you. So this kilo is 10 to the third. It shouldn't have been 10 to the second, so let's fix that. 10 to the third is 1 kilometer. Okay, is 10 to the third meters. So this should be 10 to the third here, which makes this 10 to the negative 3 here. Okay, sorry, so this is 10 to the, this would be minus 3, this would be minus 3, and this would be minus 3. Okay, so now let's take this decimal and move it over. 1.55. This number got smaller. This number has to get bigger, so that's going to be 10 to the minus 1 kilometers, and that should be correct. All right, so these are your common called SI metric SI units. So these are metric units, they're SI units. Let me write this down. And this is, they're called SI units. SI stands for System International. These are used internationally in science, in physics, in chemistry, in Europe, and in Asia. And so this is having length. You can have presented in what are called English units, but the SI units, what we use are the length in meters, or M. Okay, so basically when we measure something, let's say with a ruler, you have on a metric ruler the metric side, which measures in centimeters, but you also have the other side that measures in inches. And these units of measurements that are called the English units, these are actually based on, this is a much older system of measurement. It's based on body parts, where an inch is approximately this part of a thumb. So this was before they figured out you should use like a standard system, and people would just use their own body parts, and this is because this was the most not very much variability in that part of the thumb. So that was described as 1 inch. A foot is literally the length of a human foot, approximately. And that's how that they did this back in the olden days before they decided to standardize things. Okay, and so the English and the United States tend to use these units for measurement: inches, feet, yards, and miles. But in science and in Europe and in Asia, we use these system international units. Okay, and so what that means is that we have conversions between these two units that go on, and you'll see this with this ruler that you can measure on either side. They're both measurements are correct. It's just a matter of converting between what's a centimeter to equivalent to an inch, or vice versa. Okay, so for these numbers, you don't need to convert you don't need to memorize any of these. You can always look any of these up. Okay, but you'll need to know how to do these conversions. So volume. So volume in SI, System International, is in liters, or the uppercase L. And we've seen that in some of the problems we worked on just in the last worksheet. Mass is in grams, the symbol G. Now, a lot of these will commonly have metric prefixes associated with it, like milliliters or like milligrams, okay? Or even meters can have millimeters. And so those metric prefixes are very often associated with these units of measurement, okay? And then time is in both Europe and Asia, seconds, minutes, hours, and so on. Okay, so we can use conversion factors to convert from inches to feet, or from cups to pint, or from the English system to the SI units. And so these are equations, or conversion equations here. These are conversion factors that are already set up for you. Unlike the metric prefix where we set up a conversion factor, these you just look up. So when you have an equality, one thing equal to the other, you can turn it into a fraction and use it to cancel units. Okay, and so let's take a look at this next slide. Okay, so when you have the English system versus the metric system, most of the world uses the metric system. Those are the SI units with the metric prefixes, but the United States uses this English system. So we have to convert between these two. So you'd use a table like this. You don't need to memorize any of these, but you do need to know how to find the conversion factors, which for you guys, if you're looking at a quiz or an exam, I usually put in a little box right in the screen. And if you are just doing the Connect assignment, you have it in Appendix 1. Okay, so you can find these in Appendix 1 of your ebook, or if you decide to buy the loose leaf textbook.